Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Alright, so for today, our asynchronous lecture week number 2. Alright, and for today, we are going to continue with chapter 1, part 2. Okay, chapter 1, part 2. Okay, in our part 1, we have discussed on how to find the eigenvalues as well as eigenvectors, and also during our synchronous class we have discussed properties related to eigenvalues and eigenvectors. So hopefully all of you now, when I say the trace of A, okay, the trace of A is equals to the summation of the lambda or the eigenvalues of A, and then this is what we call as the multiplication of lambda. Okay, the multiplication of lambda A is equals to the determinant of A, of matrix A. So these are the two important properties related to the eigenvalue problem. And we do have some more where we have the relation between A inverse with A in terms of its eigenvalues and eigenvectors, A and its A transpose, okay, what happened to its eigenvalues and eigenvectors. Alright, so for today, I'm going to continue talking about some property. We're still not complete or complete the discussion on the property of eigenvectors, okay, eigenvalues and eigenvectors. So we complete the property of eigenvalue and eigenvector. We have another two property here, property number 10 and property number 11, which is closely related to linearly independent eigenvectors. Apa maksud linearly independent eigenvectors is what you need to understand today, or in other words, this is our first learning outcome for today's lecture. And we're going to proceed on how to find the eigenvalues for n equals to 3. Apa maksud n equals to 3? Kalau you perasan, in our first part of chapter 1, we are talking about 2 times 2 matrix. Okay, 2 times 2 matrix. Matrix 1, 2, 3, 4. Okay, we haven't yet discussed about 3 times 3 matrix. Yang kalau 3 times 3 matrix and its identity matrix will be 1 0 0 0 1 0 0 0 1, something like this, and as well as its A matrix also will be 3 times 3, and the most important thing is eigenvector now become 3 times 1 matrix, will be S1, S2 and S3. Alright, okay, then we are going to discuss about symmetric, skew symmetric and orthogonal matrices. Okay, this is going to be very fast, and we'll see if we do have enough time, then we're going to discuss about eigenbase and diagonalization. Okay, diagonalization. Okay, this is also in part 2 chapter in chapter 2 part chapter 1 part 2 notes, but I'm not yet sure whether today we do have enough time or not to discuss on this. Kalau kita tak sempat, then I will dedicate our synchronous class next week just on this diagonalization. This is another important topic where it may conclude the whole thing that we have learned in chapter 1. Alright, okay, that's the overview of what we are going to discuss in chapter 1 part 2. Okay, so now let's proceed to property 10. Okay, property 10 here is talking about the linearly independent eigenvectors. Okay, so macam saya cakap tadi, the first learning outcome for today is make sure you faham apa maksud linearly independent eigenvectors. Alright, so in this statement is saying that if lambda 1, lambda 2 up to lambda k are the eigenvalues of a matrix, adalah matrix A yang kita cari tu, kita dapat 2 lambda, dan daripada 2 lambda tu, of course each lambda will have at least one eigenvector, betul? Okay, we have one eigenvector, So at the end, kalau ada 2 lambda, kita ada 2 eigenvectors. So the 2 eigenvectors tu, we have to make sure that they are linearly independent. Boleh faham? Okay, how to determine that these 2 eigenvectors are linearly independent is what we are going to discuss very soon. Okay, and then property 11 pula cakap, if lambda is an eigenvalue of multiplicity k more than 1, then lambda will have anywhere blah 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 here, linearly independent juga. Ni apa maksud dia ni? This is for the case where, let's say when you factor it, you're going to have lambda minus 1 square equals to 0. So, kalau tengok kat sini, lambda ni sama dengan 1. Tapi 1 ni is a repeating. Okay, multiplicity of 2. There are 2 times 1 here. Jadi, maksudnya kat sini kan, you have to find 1 or 2 eigenvectors. You have to find 2 eigenvectors. Kenapa? Because actually we have 2 eigenvalues. Cumanya, is a multiplicity. Maknanya dia 2 kali berulang. So, you have to find lambda 1 yang pertama, lambda 1 yang kedua. Okay? And the eigenvector for lambda 1 yang pertama and the eigenvector for lambda 1 yang kedua. So, the relation between these 2 eigenvectors are also is considered linearly independent. Okay, so to faham property 10 and property 11 here, saya akan go through the example. Okay, for property 10, perhaps we go back to our previous example, say in our lecture note chapter 1 part 1, right?